Today's topic is simple linear regression. We are going to demonstrate how to perform a simple linear regression with RStudio. A simple linear regression model is any linear model of the form y equals beta 0 plus beta 1 x plus epsilon. Where beta 0 and beta 1 are real numbers, they belong to R, and epsilon is a normally distributed random variable with mean 0 and n given standard deviation sigma squared. The variable y is known as a response variable, and the variable x is known as explanatory variable. The explanatory variable x is independent, and the response variable y is a dependent variable. So let's go to R and see how to estimate these two coefficients, beta 0 and beta 1, using RStudio. So yes, let's use RStudio to estimate our two coefficients for our linear regression model, and we need the two variables x and y. For this presentation, I'm using x, the variable x being the amount of fuel in a car, in a tank of a car, and the response variable being the distance in kilometer, that can be driven using that amount of fuel in the tank. Yeah, we have the variable x and the variable y. Yeah, so how do we perform a simple linear regression in RStudio? To perform a simple linear regression, we don't need any extra library to do it. The functions that we need are built in RStudio, and the main function that we need is the function lm. Yeah. So let's call our simple linear regression model as, let's say, fit, the fitted model. And how do we fit our model? We use the function lm, and the function lm asks us a formula, and the formula takes the response variable first, followed by a tilde sign, and the tilde sign followed by the explanatory variable, and in our case the explanatory variable is the variable x. Yeah, yes, this is our model, and it is displayed here, the fit model. If we can see what it has, it displays the coefficients. These coefficients are the regression coefficients that we need. You can directly read it from here. There are two coefficients here, this one and this one, and if you there is residuals, effects, many things that you can read from this fitted model, but we are mostly interested in these coefficients and in our model. So let's see how you can display these coefficients. To display these coefficients, you can simply type fit here and call it, and if you call this fit, you get your results here. It displays the coefficients, the intercept. Our intercept was beta 0, and then it is equal to 10.515, and the slope is beta 1, which is now equal to 7.432. And if you want to write our simple linear regression, then in this case the simple linear regression will be, let me copy these values. And if you want to write your regression equation, the regression equation will be y equals equals 10.515 plus 7.432 times x. Yes, this is our simple linear regression, and these are the two coefficients that we wanted. This coefficient beta 0 and beta 1. And maybe I can also show you how we can plot this fitted model with RStudio. And to do so, let's first plot our data set, and we use function plot. We plot x and y, our variables. If we plot this, what do we get? We get a scatter plot. The graph that we get is called the scatter plot. Here is the scatter plot. Yeah, let's make it bigger. I can zoom it out like this. Yeah. We get this scatter plot. And how do we add the fitted model? There is many ways to add this fitted model to this scatter plot, and one way to do so is to use the function align, and we align our fitted model, the fit. And if we align the fit, let me use a different color, for example with a color red. Then we will get this line. Yeah, so this is the linear regression line that we wanted. And we can also, from this fitted model, we can find main information from it. For instance, if we use the function summary to this fitted model, summary fit, and call it, if I call it, I will get, what do I get? Oh, I write fit is the function summary fit. Yeah, the function is called the fit. Yeah, the output will have main things, and the output is here, and the output has this part. Let me highlight it. This part, and this part contains the residuals, our epsilon, the summary statistic of our error variable, the residuals. And the error variable, it shows the minimum, the quantiles, first and third quartile, and the median and the maximum. It also shows the coefficients, our coefficients. And this part, it display the one sample t-test for the null hypothesis that our coefficients beta 0 and beta 1 are equal to 0. If you don't know how to do the one sample t-test, please, you can go and review what you started in your statistics. But this part is a one sample t-test for the null hypothesis that these coefficients, our coefficients, beta 0 and beta 1 are equal to 0. And it displays the standard error and the t statistics. This column is the t value, this column is the t statistics, and this column is the p value for each t statistics. And the smaller is the p value. The smaller is the p-value indicate the evidence against the null hypothesis. For instance, you can see that our all two p-values are too small, meaning that the coefficients are not equal to 0. So we can we can have a linear relationship between our two variables x and y. So yeah, and the other thing that we can read from this summary statistic is the coefficient of determination known as R squared. This coefficient of determination, or its adjusted value here, adjusted R squared. Yeah. So maybe I can also show you how to extract each of these information from our fitted model. How do we do it? Is if for instance we only need to display the coefficients, we can call this command. We can call fit and then dollars coefficients. Like this, we will get only the coefficients. Yeah, we get the intercept and the slope. Yeah, so the other way to do so is to use the one sample t-test results, and that one also will display the coefficients, and it's from the summary. Then the summary, what do we need from summary fit, and what do we need from the summary? We need coefficients, yes, and this also will display coefficients, and you see we have the intercept as before here and the slope. Suppose that we only need the value for the intercept, and how do we do so? It's just to take this first element, and it is done by taking the element from the first row and the first column. If we take it, then it will be this value 10.5 and so on, which is this intercept. And if we need the slope, then we will take the value for the second row instead of being from the first row. We will take this value, then it's from the second row. Then instead of having one here, we should have two, and we will get our slope. And for instance, if we want to extract the coefficient of determination, in this case we will have to use also summary. It's the summary and summary fit. And what do we need from the summary? We need the R squared, then R dot squared, the coefficient of determination. Then we will get our value. This is the R squared. And if we need the adjusted R squared, instead of using R squared here, we add the adjusted. Then adjusted R squared, if print it, we get the adjusted R squared coefficient. Yeah. And if we need the residuals, we can use also summary and the summary fit, and then we extract residuals. Yeah, and we will get a vector of our residuals. Yes. So yeah, something else that we can do with this model is, for instance, to perform a residual analysis of our model. For instance, check for the assumptions in the linear regression model. And I'm not going to go into details, but I can show you one command which is enough to produce all the all the graphs that we need for residual analysis, and that command is the plot. And what do we plot? You plot your fitted model, the model, and if you plot it, you will have many graphs. Hit return to see the next plot. Then for instance, this plot, it shows the residuals as fitted. These are the fitted values and these are the residuals. Let me make it bigger so that we can see it. Come somewhere here. Yes. Yeah. So this is the residual versus fitted values. These are the fitted values on this axis and the residuals, and we have seen that the residuals should have should be normally distributed with mean zero. Then you see the zero is here, and if you calculate the mean, is approximately around the zero, but there is some bad data here, like this data and this, but not that much bad. Yeah. And the next plot in this plot command will be this kind of plot, TQ residuals, and the other plot is the scale location plot. Yeah. So guys, I hope you have understood something and you know at least how you can perform a simple linear regression model using RStudio. Thank you for watching and hope to see you next time. Bye.